Okay, so as I was saying, with this technique, the segmented ultralight morphing rotor, it is possible to build a more resilient and larger wind turbine that can take in more energy. And this design, it is inspired by the palm tree, which is very tall, lightweight, and can bend with the wind. So the objective of this design is for the blades to cone and morph like a palm tree. And the outcome of this is the alignment of the wind with the blades that are allowed to bend away from the tower. This design also prevents the blades from curving when we are operating at high wind speeds. Okay, by that, we have talked about the future of wind energy and how we can improve offshore wind farming. So in order to escape a fossil fuel-based future for our planet, improving the technology of wind energy systems in order to satisfy the needs of our society is a must. Offshore wind farms have proved to be an innovative approach that generate more power from wind turbines, but that alone will not be enough to surpass fossil fuels in power generation. So improvements to offshore wind turbines are now the main focus of scientists and engineers. And having stated and studied some of the most ingenious designs, such as the floating foundations and the innovative rotor design, the question still arises as to which technology will prove to be the most reliable and groundbreaking. And that's it. These are our references. Thank you.
Okay, thank you. Can you go please back to slide 15?
Yes.
Okay, Jawad, can you please summarize the main findings in the graph?
Okay, yes. So, as Antoine stated, the coefficient of thermodynamic is a really important factor in the equation to find the power generated for wind turbines. And this coefficient is it is in function of the pitch angle and the tip speed ratio. So here in the graph, we can see different curves for the coefficient of aerodynamics in comparison to the tip speed ratio for various values of the pitch angle. And you can see from it that we obviously need a high coefficient of aerodynamic. So for a CP max of approximately between 0.45 and zero point 0.5, we should have a tip speed ratio of approximately 8 in order to get the optimum power output for the wind turbine.
Okay, thank you. Can you continue with the second slide?
Here?
Just after, go. You have, yes, this one.
Oh.
Just can you tell me what are the main equations you are presenting here?
Okay, the first one here, it's the main one, the first one. It's for the rotation acceleration. We can see it is in function. Can you hear me? Okay. It is in function of the torque, the turbine torque, and and the generator torque, and they can be found. The turbine torque can be found from this equation. And as Antoine said, the generator torque can only be measured using a sensor on the body of the tower, which we can then use to find the power extracted of the turbine.
Okay, can you please go to slide 28? No, 27, sorry. Just the one before.
Okay.
Okay, Antoine, can you just give me what is the main difference between the different configuration you are presenting here?
So the difference between the monopole and the jacket.
I mean, here you are presenting several foundations types. Can you tell me what is the difference, yani what is the application for each one?
So first major difference is the depth at which each structure can go. So we can see, for example, the monopole foundation and the gravity foundation can go only as deep as 30 meter in depth, whereas the jacket foundation and the triplet foundation can go up to over 40 meter in depth. Also, we can see from the picture there the shape from which those are constructed. So the gravity and the monopole. So the monopole has a cylindrical shape, Also, the jacket has where it is the monopole, yeah, has a cylindrical shape. The tripod foundation, for example, it has two legs. The jacket foundation had three. So when we put it down in the sea, we see how it's fixed down to the sea. Also, the structure for which the gravity foundation is a cylindrical structure. Also, jacket one is a cylindrical structure. Also, what we know is that the jacket is definitely more used in oil and gas industry. So we obviously have seen this one. It's the last one on the right, the jacket foundation. It is more used in oil and gas industries.
Okay, can you go down with the slides for, you have the graph of economical comparison. Can you go for it, please?
Yes, it's this one or this?
Yes, this one. So Antoine, the previous one.
Oh, okay.
Okay,
Yeah.
Antoine, what is the cause of drop in costs between 2010 and 2019?
What is what? What is what?
What is the reason of the drop in cost with time? Yani, if you compare USD per kilowatt in 2010 to 2019, it's higher in 2010 for both
Yeah,
onshore
okay.
and offshore. So what is the
Yeah.
main causes?
Okay, so like I said also in the history introduction, in 2009, world government pushed into the development of wind energy. So they pushed in the way of producing more wind energy. So there was more resources put in that way, which led to more production. So wind energy didn't was supplied uh, more abundantly. So we know, for example, that when you want to produce something, and if you produce it on a base of a unit, it is the cost of it would be higher than if you produce, for example, 1,000 or 2,000 units. So at the production of wind energy overall increased, its cost decreased in a way. So as people and the attention to wind energy production grew, its cost decreased. So we can see that this trend between 2009 and 2019. So this is what could be explaining this decrease, I think.
Okay, thank you guys. Thank you.
Thank you, miss. Thank you
Bye
very
bye.
much.